Let us move on to the advanced questions in this topic. So we have a venturi meter here, and there's a liquid flowing from here to there. What he's asking is find the total force resisted by the flange bolts. So these are two sections. This section is one, this section is one, and they both are connected by these bolts here. He's asking what is the force resisted by them. Okay, so suppose this liquid is pushing this part, so this bolt will be applying a force in this direction to keep it still. Okay, so that force, what is that force, we need to find. Also, another thing that he has given is this is going to the atmosphere. This is open to atmosphere, so here the pressure is P naught. Okay, so if you want to find the force on this, let us first write all the forces on the section of liquid here. Okay, so if I take this section, I'll just draw this section here. See this section, I'm drawing it here. And this is what? This is a liquid. I'll just write it here. This is FBD of liquid. FBD of liquid. Now, suppose here the pressure is P naught, right? So what is the force here? Tell me. P naught into area is A. So what is the pressure here? Let us say it is P1. It is not given. So here the pressure is some P1. Area is 2A. So 2 into A. So these are the forces by liquid on this part of the liquid. What is the other force? There is this liquid is exerting some force on this, the walls of the venturi meter here. So suppose liquid exerts a force in this direction. So on the liquid, this will exert a force towards the left. We don't know whether it is towards the left or right. We are just assuming that liquid pushes this side, but this will push the liquid in this direction. So this will be force by the bolts. Why? Because if this bolt was not there, this would have gone up that way. So because the bolt is there, this is staying in place. Okay. Now these are the forces. We can write net force equal to rate of change of momentum. So I'll just write P1 into 2A minus P0 into A minus F due to bolts equal to dP by dt. Okay. Now, how do we find this dP by dt? We use the same technique that we used in during Bernoulli's equation. This whole liquid in time dt, this whole liquid is as it is. This whole liquid has gained some momentum here and it has lost some momentum here. That means this mass has come here and this mass has gone here. Because this mass has a specific velocity and because some other velocity, overall this has lost and gained some momentum, right? So that from there we can write what is the change in momentum. So let us write what is the change in momentum. So 2P1A minus P0A minus the bolts equal to, I can write this as dm by dt. And what is the change in velocity? This part, what velocity it has? Tell me. Here, if it velocity is v0, here velocity will be 2v0. So 2v0 minus v0, this will be v0. Okay. Now see, what is dm by dt is nothing but mass flow rate. Mass flow rate is rho into a into v. So yes, this part we know. We don't know what is P1. We need to find what is P1. Once we find P1, yes, we have what is the force due to bolt. Now what will be P1? Tell me. We have already seen that what is delta P? In such cases, delta P equal to rho naught minus rho into G into H. Rho naught minus rho into G into H. For such cases, for such a design of Venturi meter. So we can just put this here. Delta P is nothing but what you call P1 minus P0. P1 minus P0 equal to whatever this is there here. So I can directly write my P1 here as 2A times P0 plus rho naught minus rho G into H minus P0 A minus F due to bolts equal to what is mass flow rate rho into A into B? Rho into area. I'll take this, okay, because we know velocity here 2A. Rho into area into velocity is V naught into V naught, V naught square. V naught square. That's it. Okay. So we can just simplify this and we can get what is F bolt. I'll just simplify this. So 2A P naught plus rho naught minus rho GH minus P naught A minus F bolts equal to 2 rho A V naught square. Okay. Finally, if I just write the final expression, F bolts is how much? We will take it this side. Here P naught A, this one will get cancelled, one will get cancelled. So we get P naught A plus rho GH 2 rho A V naught square. Okay. So this will be the expression for what is the force on the bolts here. Now will this be positive or negative? It depends. It depends on these velocities. It depends on these values of these things. Okay. So from that we can say whether this is in this direction or this direction. But the magnitude will be this.